Okay, welcome students. In our today's session, we are going to see projection of solids, which is nothing but a cone. I hope you know what is a cone. A cone is nothing but solids of revolution. If we rotate a right angle and triangle, we can have a cone. Okay, the problem which is given very clearly in the description, you can see the base diameter is given as 40 mm and the altitude is 80 mm, which is the height, and it is given as the axis is inclined at 30 degree to HP, which means it is parallel to VP. And similarly is given as the base diameter and HP. So we know that obviously if the base is available in horizontal plane, if you look from the top, we can see the circular shape. Okay, so here I have drawn the simple precision yearly. See here, this is my top view. In top view I can see this circle, and in the front view I can see a triangle. So obviously you know that if you draw a circle, it can be divided equally into 4 equal parts, 8 equal parts or 12 equal parts. I have been mentioned earlier very clearly that if you divide your circle into 12 equal parts, the position, the final position what you will get will be very clear. So for my easy drawing, here I have been drawn only as a 8 equal parts. Okay, so this is my top view. From here I have projected and I have been completed my front view. Okay, so you be very careful. Most of the people would forget this base where it is been resting. So I can draw here as 1 dash, so 2 dash, so 8 dash is written, so 3 dash and 7 dash, so here it is 4 dash, bracket 6 dash, and it is 5 dash. So you can see here I have drawn only the outermost cone as a dot, because the thing what I have drawn here is everything is imaginary. So that only I have drawn the inside directories line as very light and very thin. Only the outermost part of the cone should be darker. This is the same thing we have to follow in our cylinder problem also. So since it is given here very clearly, the axis is inclined at 30 degree to HP and parallel to VP. We obviously know one condition, if anything is represented in the horizontal plane, we call it as a front view. Here the front view is nothing but a triangular shape in which the axis is inclined at 30 degree. We know one concept, if the axis is inclined to 30 degree, we will do one small calculation, 90 minus 30, which means 60 degree. So the base is inclined as 60 degree. So this is very important. First you have to check whether the axis is inclined given or the base is inclined given. Here it is very clear, axis inclined is given. I converted the problem into base inclined. So what I have to do is, first I need to draw a line which is inclined at an angle of 60 degree. So this is an angle which I measured 60 degree, and I pin my right hand side, which means it is 5 1 dash. That is amethyst. Using my compass, I can measure from 5 to 1, so that I have my point here as 1 dash. Similarly, I can measure from the center point. So from here I am measuring it. I have my center point, where the center point is given as 3 1 dash. Within the bracket, it is given as 7 1 dash. Similarly, from the center point I am having 2 more points, from 3 to 2 and 3 to 4. So here I am having 1 point and here I am having 1 point. I am using my compass. With my compass I am measuring it and I am taking it over here. So it can be marked as 2 1 dash, within the bracket 8 1 dash. This is 4 1 dash, within the bracket it is 6 1 dash. You make sure that all the points here is being transmitted over that. Then what you have to do, I am having a center line here. This center line should be perpendicular to this 60 degree line. Okay, so now I am drawing a line which is perpendicular to this particular 60 degree line. Okay, and I know obviously what is the height given in my problem. The height given is 80 millimeter. Using your scale, what you can do is you can measure 80 mm and you can fix a point here. Okay, once you fix a point, you try to complete it, the particular diagram. That's all. So your center line should be very light and very thin. Okay, now what we have to do is, we have to project all the points from the top in order to complete my final question. See here, it is not necessary you need to draw this particular line, but you try to have this as very light and very thin, since I need to project these points towards the bottom. So I am projecting this point number 1, I am projecting point number 2 and 8, I am projecting point number 3 and 7, I am projecting point number 4 and 6. I am projecting point number 5. Very clearly, don't forget your point number O. It is very important. Okay, and now similarly, you project it from here. This is point number 7. So this will be my point number 8 and 6. This will be point number 1 and 5. This will be my point 2 and 4. And this will be my point number 3. So if I try to complete, you try to first fix all the points. So this is my 7. This is my 7. And yes, obviously this is my 2, 1, 8, 1. This is my 2, this is my 3, 4, 5, and then I am having my 6 here. Okay, so be very careful. You obviously know that if any corner or edge is resting, first actually that will be hidden line. So this is my point number 5, this is 4, this is 3, this is 2, this is 1, this is 8. This is 7 and 6. You can see corner 5 is resting. So from 5 to 7 it will be hidden line. It is a concept which I have told already. Since this corner is resting, it can be drawn. So to draw this curve, you can use your French curve. So using the French curve, we may have a curve shape in which you can try to join all these curves. And finally, I am trying to complete the particular portion. As I told earlier, we know that only the outermost part will be darker. You can see the 7. So I forgot about the O to project the O here. So this is our O point. So this is our point O. Let us have it as 1 in organizers. Because that is what we are following in our problem. Okay, so now you try to complete like this. So 7 to O and similarly O to 3. So this is our simple position and this is our inclined position. In order to complete your dimension, what you can do is, so you obviously are having your line like this. You try to have an arrowhead here, and you try to have an arrowhead here, and try to have a line here, and it is diameter 40. Okay, and we obviously know here axis incline only is given over here. So you try to extend your axis here and mark it as. So this is my 30 degree. This is my 30 degree. And similarly, I need my axis height. So draw an extension line, draw a dimension line, give your arrowhead at the bottom and at the top, and the height given is 80. So with which we have completed the problem.